Okay, so we are going to discuss about coordinate geometry. First of all, for this, the Cartesian plane is involving Cartesian plane. So x and y. Now, this is Cartesian plane is a 2D plane, so two-dimensional x and y. So that means you have two variables x and y. So x is called independent and y is called dependent. Now, if you want to make a straight line, you can have 2 points minimum and have a straight line. So the initial coordinate would be x1, y1 and the final coordinate would be x2, y3. Now it's true that you can have another point on the line and that point would be x3, y3. So but however, all these 3 points are collinear. Collinear means on one straight line. Now the most important thing here would be to find the slope of a linear line. So the slope of a linear line is given by the tan theta value. What is theta now? Theta would be the angle with the horizontal axis. So this is theta. So angle would be the angle measured. Theta would be the angle measured from the positive x-axis. Okay, so as you can see in the diagram. So the tan theta value. So now since this is a straight line, what we know, we can have a right angle triangle and we can have the opposite and the adjacent. So this would be y3 minus y1. Sorry, this is y2 actually, right? So it was a mistake. So it's going to be now y2 minus y1, and then this one would be, this bit would be x2 minus x1. So that's why you get y2 minus y1 divided by x2 minus x1. So so this whole thing, the whole thing would be x2 minus x1. So this is this slope. Now if you calculate the slope, typically we denote by m. Okay, sometimes we call it gradient. So when you learn calculus, differentiation, you will learn more about it. So this is a positive number. This is a positive number. Now if you have a slope like this, if you have a slope like this, the theta value is greater than 90 degree. So obviously tan theta is going to be a negative value. So that means the gradient slope is a negative value. Now it's very, now geometrically I will show you why it is negative. So this is your x-axis, this is your y-axis. Now let this coordinate to be x1, y1, and this coordinate would be, suppose, x2, y2. So now here essentially you can't find the theta value because you know right angle triangle has this value alpha. So what we do, we find the alpha value. So that would be tan alpha. So we will take tan alpha. So tan alpha would be this height. That would be y1 minus y2 divided by the distance here. So that would be x2 minus x1, right? So now since we are unable to find the tan theta from this right angle triangle, what we do simply, we find the gradient. So the gradient is tan theta, and that is nothing but minus times tan alpha. So this tan alpha part is a positive number. So ultimately you will get a negative number. So now we will understand a special case. In xy Cartesian plane, if you have a line which is parallel with x axis, and what would be the slope here? Okay, so and there is another line which is parallel with y. So we understand that the angle which is measured here is 0, because always the angle is measured with the positive x-axis, positive x direction. So always we measure the gradient from the positive x-axis, positive x direction. So it's 0 here. So for this, tan 0, tan 0. So now with this vertical line, this angle would be 90. So gradient would be tan 90. So you know tan 90 is infinity. So if you have a vertical line, the gradient is infinite. Okay, so now we will learn how to find the distance, the length of a straight line. So now suppose we have 2 points here, x1, y1, and the end point would be x2, y2. We need to find this d. D means the distance of this line, right, A to B. So now this is a right angle triangle. Now what we do is we will do Pythagoras theorem. So using P theorem. So using Pythagoras theorem, I can say, okay, so let's say this point is P. So d squared is equal to bp squared plus ap squared. So now what is bp? So bp would be y2 minus y1, and ap would be x2 minus x1. So what I will do, I will plug that one over here. So bp would be y2 minus y1 whole thing to the power 2 plus x2 minus x1 the whole thing to the power 2, and that is d squared. So now d would be square root y2 minus y1 squared and plus x2 minus x1 squared. So that's the distance of a line when the points are given. Okay, so equation of a straight line. So we will try to derive this. Firstly, we will have a line like this. This point is called the y-intercept. We will say that would be C. So the coordinate would be 0 and C. And we will take this coordinate as x and y. So we have tan theta here, which is the gradient. So our gradient would be tan theta. So that can be written as, so the opposite side would be y minus c. The adjacent would be x minus 0. So that would be y minus c divided by x. Now what I will do, I will do the cross multiplication. So I will multiply x with m. So you get mx is equal to y minus c. So from here you get y is equal to mx plus c, and that is the general equation for a straight line, where m, if you want, you can replace m by tan theta, but m is the gradient. So c is nothing but y-intercept. So now in this example, we have to find the equation of the line. So the gradient is given in the question. Now what we have to understand here is this. So minus 1 and 3, so that means x is minus 1 and 3 should be somewhere here. So the point is here, minus 1 and 3. So the line goes like this, right? So line goes like this. Now the gradient is given to you, 4. The general equation of the line would be y is equal mx plus c. Now importantly, what we have to understand is, what is the meaning of this equation? The meaning of this equation would be this. What is x and y? Those are variables on the line. So how many coordinates we can have on this line? Infinite number of coordinates we can have here, right? So here, 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 everywhere. So all these points are going to be satisfied by x and y. That is the meaning here. The meaning would be all these points. If you take this point and put into the equation, that x and y is satisfying this equation. So I can write it 4x plus c. So all the points on the line should satisfy this equation. So that means left hand side should be is equal to right hand side when you plug the coordinate. So what we will do, so you have to plug the coordinate into the equation. So y value would be 3, 4, x value would be minus 1 and plus c. So you need to find c. So this is going to be minus 4 and c is going to be 7 now. So accordingly you find y is equal to 4x plus 7, and that would be the answer to this equation. So now in this topic, parallel lines and perpendicular lines. So firstly I will discuss parallel lines. This is very easy. So if you have two lines like this and they are parallel to each other, what would be the requirement should satisfy to have a parallel line? So yeah, so suppose this is theta 1 and you should have theta 1 over here. So the gradient, should be similar to each other. So that means m should be is equal to tan theta 1. So that is the only requirement. So the gradient here and gradient of the other line should equal to should be equal to each other, but they can have different y-intercepts. So you have c1 here, you have c2 here. So for this line I can say the equation is y is equal to mx plus c1, where c1 is the y-intercept. For the other line you can say y is equal to mx plus c2, where c2 is the y-intercept of the other line. So now the second one would be the perpendicular lines. So in perpendicular lines, so the proof is not needed, the relation between these gradients, but the relation I will show. Suppose there are two lines where this line would be y is equal to m1x plus c1, and this one is y is equal to m2x plus c2. Now if those two are parallel to each other, perpendicular to each other, then the requirement would be m1 times m2 should be is equal to minus 1. So this is the requirement. So the proof has a geometric proof which is not required here, but this would be the condition. So the condition for the parallel line would be the gradients are equal to each other. So the perpendicular condition would be m1 times m2 is equal to -1. So in this question we have two equations given. One is 4x minus 3y is equal to 10 and 4x minus ly is equal to m. So, and these two are perpendicular to each other. So then when you have a question like this, what we have to do first, we have to rearrange this question, which is 4x minus 3y is equal to 10. So I'm going to subject y here. So that would be 4 divided by 3x minus 10 divided by 3. So this is my first equation. Then I will take the second equation, which is 4x minus ly is equal to m. So here if you subject y, you should get 4 divided by l x minus m. So this is my second equation. So the question says first equation and the second equation are perpendicular to each other. So that means the gradient over here and the gradient of the second line, so suppose this is m1 and m2. So what you can do, you can use the formula we have derived, which is -1. So this is going to be now 4 divided by 3 times 4 divided by l is going to be -1. Now you can further simplify this one, which is 16 divided by 3l is -1. So from here you can get l is going to be -16 divided by 3. Okay, so now in this question we found l value. So l is -16 divided by 3. So let me consider that as my third equation. So y would be 4 divided by, now I'm going to substitute for l, that would be -16 divided by 3. So -16 divided by 3 x minus m. So if you simplify, you get y is equal to 12 divided by, so it's minus 16x minus m, and y is equal to, now you can simplify this by 4 now. So it's going to be -3 divided by 4x minus m. So this is my fourth equation. But there is a problem. The problem is this m we have to find. So yeah, so we have given a point which is on this line. So what we do is we will sub in that value into this equation and find m. So 4, 2 is given. So okay, so 4 is the x value. So y is 2 minus 3 divided by 4, x is 4 here, minus m. So you can cut these two off. So you get 2 minus m. 2 is equal to -3 minus m. So from here you can find m, that would be -3 minus 2, which is going to be -5. And then we can rewrite the equation. The equation is, after finding the gradient and m, -3 divided by 4x minus -5. So that would be -3 divided by 4x plus 5. So that's the answer to this equation. That's the answer to this question, right? So this is the equation we obtained, and that would be the answer to this question. So next topic would be midpoint of a linear line. So let me draw a general line x and y here. So I take the initial point as x1, y1, and then take the final point as x2, y2. So the midpoint is somewhere here. So we have to now find the coordinate of the midpoint. Now if you look at this carefully, this length over here is equal to the length over here. Why? Because that's the midpoint. And similarly, this one, the vertical line over here is equal to the vertical line over here. Now if you consider the y value at this point, that would be y2, and the y value at this point. Okay, so first of all we will write the coordinate at that point. So the coordinate x would be x2, but y would be y1. So the y coordinate at this point would be y1 plus y2 divided by 2. Similarly, the x coordinate at this point would be x1 plus x2 divided by 2. Why? Because that's the middle point. So we can say then the midpoint of a linear line here has the coordinate of this, which is the x value, and this, which is the y value. So that would be x1 plus x2 divided by 2, and then y1 plus y2 divided by 2, and that's the coordinate of the midpoint. Okay, so in this question, y is equal to x minus 1 squared plus 2 and y is equal to px. P is not given. Okay, they are intersecting each other, and we have to find p to have only one intersect. So now we have to go to this go to a diagram and see like what is happening here. So now the first one is a parabola, right? And y is equal to px is a linear line. So y is equal to px is a linear line. So this p is a constant. So you can have a situation like this where you have two intersects. Also you can have a situation like this where you have only one intersect. Also you can have a situation like that here, no intersect. Okay, so that means here you have two solutions, and here you have one solution, and here you have no solution condition. Now if two graphs are intersecting each other, that means you can equate those two, because at these points the functions are equal to each other. So what you do, you equate those two. So px is equal to x minus 1 2 plus 2. Now what I will do, I will simplify this one. So px, so right hand side I will simplify, which is this plus 2. Now if I further simplify, you get x squared minus 2x plus 3 is equal to px. Now it becomes a quadratic. Now what I will do, I will put this one to the other side and write like this. So minus 2 plus p x plus 3 is equal to 0. Now the question is asking to find the p value where this quadratic has only one solution, right? So now we have a quadratic equation here. Now the question is asking to find the condition or find p value where this has only one solution. So one solution means one intersect. So we know the discriminant. So for a one solution, b squared minus 4ac. So what we have to do is, what is b squared now? 2 plus b squared minus 4 times 3 is equal to 0. So you get 2 plus p 2 is equal to 12. So 2 plus p would be square root 12. So you put plus and minus, then p value would be minus 2 plus and minus square root 12. Okay, so here we don't have to simplify it. If you want, you can simplify it, but we can generally keep it. That's no problem.